Hi, welcome to physics class. In today's class, I want us to run an experiment in optics, and the experiment is titled Refraction of Light through Biconvex Lens. The biconvex lens is also called the converging lens. The biconvex lens is the name given because of the shape of the glass, while converging is given because of the function of the shape of the glass. So without wasting more time, I'll go straight to the business of the day. So let me use your pen, your raw materials, and draw this for me. This is what we mean by the biconvex lens. You help me draw a line of symmetry down here, and then a straight line passing through here. Now, before I proceed to draw this, the biconvex lens have similar properties. These two, after reflection of light at the surface of the mirror, the light rays will converge at a point. And you can see the application of that with the mirror project we did the other time. This is it here. This thing where the pot is placed here is where the rays are converged when the light hits the surface and they reflect back. And whatever you put at this point, if it is food, you are going to cook your food. And so that is the application of reflection of light at curved mirror surface. Similarly, the biconvex lens does the same work by converging the rays of light when they are done refracting at the center of the lens, meaning the rays of light after refraction at the lens will converge at a point. That point of convergence is called the focal point. And similarly, right here, this place is called the focal point. The focal point of the mirror. Without wasting much time, I will love to do a sketch on the board for us to see what happens with this guy here. So let's suppose that this is radiating its rays. And the rays of sun, this is the principal axis of the lens. And the rays will fall down here. If the ray passes through the center of the lens, the rays will refract through undeviated. And so this point of convergence, we call it the focal point. So at this point, whatever you place at this point will be set ablaze, or you can cook something at this point. But this is not properly drawn. Let us look at the proper geometry of this lens so that we can use the geometry to run our experiments. Now, while drawing the lens, there are three rules governing the ray diagrams in lens. The rules are as follows. In no particular order, the rules are as follows. Rule number one. A ray of light passing through parallel to the principal axis. This line is called the principal axis. And then somewhere here we have it, I'll explain that here later. This is F, and this is 2F. This is F prime, and this is 2F prime. Good. Now, if we are choosing this side of the lens as the source of our light, everything here becomes F prime and 2F prime. But if we are choosing the side of the lens, everything here becomes F prime and 2F prime. Similarly, the distance from this point to this point must be the same as from this point to this point. That is to say, if you have from here to here 2 cm, from here to here must be 2 cm. From here to here 2 cm, from here to here must be 2 cm. So if a ray of light is passing parallel to the principal axis, This place is called the center of curvature of the mirror, of the lens. After refraction of the lens, the ray will pass through this. Rule number 2. 2f, and here's supposed to be our f prime, and then here's supposed to be our 2f prime. And this is our line of symmetry. So a ray of light passing through here, a ray of light passing through the focal point of the mirror, of the lens, after refraction, it will pass parallel. The last rule. So this one states, a ray of light passing through the center of curvature, after refraction at the lens, it will pass through it undeviated. So for you to be able to have a perfect ray diagram for a lens, you must have to combine 2 or 3 of the rules. Are we good?
Yes, sir.
Are we good?
Yes, sir.
So right now we are going to draw something on the board quick. Please pick up your rulers. From here to here is 2 cm. And this is 2f prime, 2f. And from here to here, this is f. Make sure that while you are drawing, the distance from C to 2f should be the same as the distance from F to C. From C to F, we are using 2 cm each. 2 cm, 2 cm. 2 cm, 2 cm. That is from C to F, you have 4 cm. From C to F, from C to 2F prime, you have 4 cm. From C to F, you have what? 4 cm. Are we good? So we are going to draw just one ray diagram. And then we're going to generate our table of values and then run the experiment. Are we good? Correct. Now, we want to use this side as the source of our light. And so the object will be placed here. From this point to this point is called the object height. Now we're going to use 2 cm as our object height. 2 cm as our object height. So combining the rules for drawing ray diagrams, we're going to use rule 1. A ray of light passing through parallel to the principal axis. Please ensure that your object height is not above the aperture of the lens. Where will it pass? It will pass through F prime, right? So the ray will pass through F prime. Are we good? And then you must indicate the direction of travel of the ray. Now take note that this is the incident ray, and this is the what? Refracted ray. They bounce back to space. So this is your incident ray. This one, your refracted ray. Are we good? Yes. Are we good?
Yes, sir.
Now, we're going to use another rule again. A ray of light passing through what? Through C, right? After refraction, it will pass through it undeviated. Are we good? So this point of intersection is where the image is formed. At this point, you draw a line straight down here and an arrow with an arrowhead down. And this is the image. So the geometry proper. Where the object is placed to this place, to the center of the lens is called what? The object distance. And where the image is formed to the center of the lens is called what? The image distance. From this point to this point is called what? The object's height. And from this point to this point is called what? The image height. Now, from where we have 2f, from f to 2f, is called what? The radius of curvature of the lens. I say it again. From f to c is called what? The radius of curvature of the lens. Are we good? Then from 2f to c is called what? the focal length of the lens. For that reason, we have two focal lengths. We have what? 2f and then what? 2f prime. So from this point to this point is also what? The focal length. Are we good? So from this point to f prime is what? Now in summary, what we are going to do in our experiment is this. We are going to make use of the following lens equations. 1 over f is equal to 1 all over v plus 1 all over u. That is to say, the object, the focal length, any error here? No. Any error on the board?
Yes.
Where is the error?
F and 2F.
From here to here is f.
That's meant to be 2F.
2f. Good. Please clap for her. So we have students who are following. So we have f and then we have 2f, right? So we have f prime and then we have what? 2f prime. So from f to c is what? From capital F to C is what? Focal length, right? And from here to here is also what? The focal length. And this can be our f small f prime, right? So the focal length, the object distance, and the image distance are related with this mirror or lens equation. The equation is used for both mirror and what? Lenses. Number 2. That's our equation number 2. The next equation is image distance V over what? Object distance. Or what? Image height. This is image height. Image height over what? Object height. What's the unit? What's the unit? It is a dimensionless what? Quantity. Because cm cancels out what? Cm. The last equation is what? This is equation number 3. That's what? 1 over f. In the unit of what? In the unit of what? And with a capital what? D. So what we are going to do in today's experiment is as follows. Write down the table of values. The parameters that we are going to measure in the experiment are as follows. We have the focal length for every lens is a constant. Are we good? So the focal length will be on top. And the aim of our experiment will be to find the focal length and also the magnifying what? Power of the lens. We are going to find what? The focal length, the magnifying power, and what? The converging what? Power of the lens. We are going to do the experiment 5 times. 1, 2, 3, 4, 5. So we have the focal length, we have the object distance, right? In cm, right? Slash cm. We have the image distance slash cm. Good, we'll find R in our experiment. So at this point, we are going to run the experiment. I am going to run just one of the experiments, and you guys will help me do the remaining part of the experiment. Are we good to go? Now, we are about to run the experiment proper now. But before I proceed for the experiment, there is something I want to tell us, guys. What is that? The precautions for the experiment. Every experiment in physics has precautions. How cautious were you during the experiment? If you are not cautious during the experiment, you are not going to get accurate results. For this reason, precautions are very, very important in physics. And you don't state precautions saying we. The way you state precautions for the real experiment is not the same the way you state precautions for what? Alternative particles. Now for this experiment in particular, these are the peculiar precautions. And so you have to avoid error due to parallax. Error due to parallax are error due to the usage of apparatus. And in this case, the major apparatus is what? the meter rule, I say it again, error due to parallax are error due to the usage of measuring apparatus, like the meter rule, the ammeter, the voltmeter, the measuring cylinder, right? So in this case, this is our measuring what tool in this experiment.
Yes,
Now permit me to introduce to you the apparatus in the experiment proper. This is a ray box. The ray box is standing for the object height I was drawing on the board there. This meter rule is now serving as what? Your principal axis, the lens holder, and this is the lens. The lens holder is serving as the line of symmetry for the lens, or it also gives us an idea of the center of the lens. Are we good? And here is the screen. Every image that is formed on the screen here is called what? A re-image. Re-image are those images that can be formed on the screen. While virtual image are those images that cannot be formed on the screen. So I am going to run one of the experiments, and we are going to use what the values to find what our focal lengths. If you observe very well, you see that the lens holder also has a line here. That is where all your reference will take your measurement will take the reference point. Are we good? Also, the screen has a line here. That is your reference point. Are we good?
Yes,
Now let us run one of the values. We want to place our object at 20 cm. So the zero end of the ruler is here, right? At 20. At 20 cm. At that point, we are going to adjust 20 cm. We don't know our V. We don't know our F. So from 1 over F is equal to 1 over V plus 1 over U. We want to, our U is given, we want to find our V and then our F. We use our V and U to find what our F. So the lens is at what? 20 cm. So we are going to adjust. Do you see any image? Do you see any image?
No.
Magnified image that you cannot even contain the screen again, right?
Yes, sir.
Right?
Yes, sir.
Do you see that?
Yes, sir.
A sharp and what? Magnified what?
Image.
At this point, you can take your reading, and the sharp image is formed at what? 80.12 cm, and that is that's not image distance. Image distance, this time is what? 80 point what? 123.3 minus what? 20. Why is that?
60.3.
And so our V is what?
60.3.
60.3 cm. So our F is what? 1 over what? 20 plus 1 over what? 60.3. You find your LCM and then you get your answer. So this is what we are going to do in all of the experiments. You can see a magnified and sharp image. So having gotten sufficient theory knowledge of how light can be refracted through the lens, I hereby release you to go and run the experiment while I sit and watch. I am going to select 2 best students from the experiment. sure that this is aligned here. And it's zero here. Right. Progress. Are we done the experiment? Now help me observe the trend of the experiment. All of you, help me observe the trend of the experiment. Is it increase, decrease, or increase, increase?
Increase.
So what graph are you supposed to have by condition?
Straight line graph.
Increase, decrease is straight line graph. A negative graph, right?
This is Mata Ecclesiae College, located in the city of Ekpe, Lagos State, Nigeria.